Hi everyone. This is a very interesting question in more ways than one. To start with, it tests concepts in algebra, quadratic equations, and properties of numbers. Right? Let's get started. It's a select one or more answer question. If the equation x square plus bx plus c equals 0 has roots that are both prime numbers, this quadratic equation has got two roots, both the roots are prime numbers, which of the following could be true? Let's spend a minute on understanding what this is subsequently, right? Could be true, what does it mean? Must be true, what does it mean? Indicate all such options is what they have said, right? We'll start with which of the following could be true, that part, which essentially means that the opposite of what could be true is something that's definitely false, right? Essentially, if we say that which of the following could be true, it may be true sometimes, it may not be true sometimes, but if there's a possibility of it being true, we'll have to select such answers. What should we not select? We should not select such an answer which is definitely false. So we'll find out whatever is definitely false as we are going through, and we find something that's definitely false, we'll strike it off. The other things, sometimes it could be true, sometimes it could even be always true. It doesn't matter. Could be true leaves us with two possibilities. Sometimes true, sometimes not true, that possibility. Always true, we'll have to pick that. What we should not pick is something that's definitely false, right? Before we look at the answer options, let's quickly get a handle on what is said. Sum and product of roots and the coefficients of a quadratic equation. Let's get clarity on that. First and foremost, let's say the roots are alpha and beta for this quadratic equation. X square plus bx plus c equals 0 is this quadratic equation. Sum of the roots for us for an ax square plus bx plus c equals 0 would be minus b by a. So alpha plus beta for us will be minus b by 1, which is equal to minus b. So what does b therefore translate to? B is equal to negative of the sum of the roots. The sum of the roots is equal to minus b. So multiply both sides by minus 1. We'll get b is equal to minus of sum of the roots. Now, the product of the roots alpha beta is equal to c by a. For us, that's going to be equal to c by 1. So, c is equal to the product of this roots alpha beta. So, this much we got clarity from sum and product and the coefficients of this. So, what is going to be the value of beta? It's a negative of sum of roots. What is going to be the value of c? Which is a product of the roots. Right. Now, let's get some more inference in place. Both the roots are prime numbers. Both the roots are prime numbers. The smallest prime number that we have is a 2. The rest of the prime numbers 3, 5, 7, so on and so forth go on. So all of these are first and foremost positive integers. So both the roots are positive integers. Right. The second inference I'm drawing is 2 is the only even prime. These are not inferences, these are informations known to us. Any other prime number is an odd number, right? So let's have these things. So let's make inferences about b and c. So alpha is a positive integer, beta is a positive integer. So alpha plus beta is going to be equal to a positive integer. So the value of b, what did we say b is? B is negative of alpha plus beta. So b is equal to negative of a positive integer, which translates to the fact that b is a negative integer. What can we say about alpha beta? If alpha and beta are both positive integers because they're prime numbers, then the product will definitely be a positive integer. Alpha beta is equal to a positive integer. Alpha beta is the value of c. So few inferences that we have drawn is that c is a positive integer, b is a negative integer. There's some more that we'll need, but let's proceed. Let's now take a look at the answer options and find out which of the following can never be true. Which of the following can be sometimes true, and which of the following will be always true. Sometimes true and always true will be a part of our answer options. Start with part 1. B is a prime number. Right, look at it. What do we have here? B is a negative integer. Prime numbers are subsets of positive integers. So if B is a negative number, B can never be a prime number. Never a prime number. B never a prime. So this information is always false. So which of the following could be true? Something that's always false can never be true. So A is not the answer, right? Done. Is it clear, right? So we've understood that b is a negative number because it's minus of alpha plus beta. Alpha plus beta is a positive integer. So negative of a positive integer is a negative integer. A negative integer can never be a prime number. Move on to the second one. C is a prime number. What is C? C is equal to alpha beta. This is a prime number. This is a prime number. Product of two primes can never be a prime number. So C is also never a prime number. If it is never a prime number, it could never be true. So could be true is ruled out for this also. So B is also not the answer, right? Quickly we've been able to eliminate these answer options. Move on to the third one. B is negative. We've established that, right? So B is negative is actually always true. So can it be true? It could be true. So definitely C is one of our answer options. Move on to answer option D. C is negative. We established C is equal to alpha beta. Both are prime, which means both are positive. Product of two positives will always be positive. C can never be negative. C can never be negative. So we are saying this is can never be true. This information C being negative is always false. It's never true. So could be true is not possible for this. So D is also not our option. So of this we have ruled out A, B, D. C is the only thing which is always true. So it would definitely fit into the could be true. Move on to E. B and C are both even. Okay. Even numbers exist in both positive and negative spectrum. So -2 is also an even number, +4 is also an even number, right? Now let's look at it. See, we know that alpha, beta are primes. Okay. Now B is equal to minus of alpha plus beta. C is equal to alpha beta. Let's start with this, or whichever, we'll start with this. If one of these two numbers ends up being even, the product will be even. So if alpha or beta or both of them end up being 2's, right? So this could be 2, this could be 3, this could be 3, this could be 2, or both of them could be 2. In that case, alpha beta will definitely be even, right? So C being even, there is a possibility. We have figured it out. When will alpha plus beta be even? Alpha plus beta will be even when either both of them are odd or when both of them are even. Something like minus of 3 plus 5 is a possibility. Both of them being even, do we have two even primes? Not possible. But do both these numbers, roots, do they have to be two different numbers? Not necessarily. We took it here, right? Minus of 2 plus 2 is also even. Can B and C both be even? Yes, -4 is even when the roots are 2 and 2. +4 is even. The product is even when the roots are basically 2 and 2. We shouldn't miss out the possibility of both the roots being the same value, because in quadratic equations, the roots can be distinct or the roots can be equal. Roots can be equal when the roots are basically 2 and 2. We will have B also being an even number, C also being an even number. Both are simultaneously even. That's possible in this scenario. Only scenario where it's possible that simultaneously B and C are even. So this could be true, right? Only scenario, but is it possible that it is true? Yeah, it is possible in this scenario. So E is our answer, one of the answer options. So till now we got C, now we got E as well. Let's look at the last one. This is interesting. C is what? The value of alpha beta. Modulus of B. Essentially, we know that B is nothing but negative of alpha plus beta. You take this is negative of alpha plus beta. You're taking a modulus of this. So essentially, we're picking the value of sum of the roots. So what we are saying is product of the roots, that value is greater than or equal to sum of the roots. What information do we have? We know that both alpha and beta are prime numbers. So the least value that alpha and beta can take is equal to a 2. So let's say they are 2 and 2. This would be a 2 plus 2. This is a scenario where it is equal. If you have two positive numbers, this is an important property for you to know. If you have two positive numbers, both of which are greater than 2, right? Let's say this is a 3 and let's say this is a 5. Then 3 into 5 will definitely be greater than 3 plus 5. I'm giving you the property that if you have two numbers, both of which are greater than or equal to 2, right? You will have that product being greater than or equal to the sum. This is a property that we can say. So if both of them are 2's, then at that point in time, it is equal. Both of them are greater than 2, then the product is greater than the sum. If one of them is a 2, the other is greater than 2, then even then the product will be greater than the sum. So for example, 2 into 3, if you want to just stick to integers, this is going to be equal to 2 plus 3. 2 into 3 is greater than 2 plus 3. So C will be greater than or equal to modulus of B. This is also always true. So we have C which is always true, F which is always true, and E which could be true. When can it be true? When both the roots are 2's. So what are our answers we have? The answers we have are C, E and F. It's a lovely question, right? Tests multiple concepts, a very difficult one, right? Go through it once more if you feel like, right? This will give you good understanding about multiple concepts that are tested in the GRE. Have you subscribed to our channel? If so, thank you so much. If you have not subscribed to our channel, please subscribe to our channel and turn on notifications. You'll get notified every time we upload a video, either in verbal or in quant or in data interpretation or anything related to an update about the GRE. Best wishes for your GRE preparation.